So we have increasing and decreasing intervals. So the section or interval of a graph that is, you can say it's going up and to the right. Oh, thank you. Oh, anyone else need to sign in? Oh, there you go. Oh, I just pass it back, please. Thank you. Just for a section. Now, it's possible the entire graph is increasing, but just for a section of the graph. Let's say, from A to B. Is increasing on that interval. Okay. Thank you. Now, if you have a graph that's going down and to the right, that would be decreasing. TI for a section. Is decreasing on that interval. Okay. Now, if you notice, I have the interval in parentheses instead of brackets. And the way you can remember that is think of throwing a ball. If you're throwing a ball, at some point that ball is just going to keep going up and up and up and up and up. Now it's increasing as long as it's going up. Then at some point it's going to stop. It's not increasing or decreasing, it's just stopping right there. And then it's just going to decrease. So let's say we call this point A, point B, and we call this where it hits the ground, point C. Now you notice it's increasing all the way up until you get to B. When you get to B, it stops, even if for a split second. Then it decreases the other way. Increasing from A to B. If you notice here, it's decreasing. Cleaning that up a little bit. From B to C. Remember, it's always going, you're always counting it to the right. Okay. Any questions on that one? Oh, straighten that up a little bit. There we go. All right, I'll leave that up for a second. All right. Okay, so let's say, for example, actually, I printed out some. Make sure we got, here we go. Say if we want to determine the intervals for which this particular function is increasing. So if you notice, it's increasing. Let's see if I can highlight it. For this section right here. Okay. That means it's increasing from this point, which is x equals -2, to x equals 0. Okay. So that means your interval would be from -2 to 0. At least for increasing. They didn't ask for decreasing. If you're just decreasing, then you would have, say, from -infinity to -2 and 0 to 1. Or 0 to infinity, since it's going all the way down. But this one just wanted the increasing. Uh-oh. Okay. Any questions on this one? All right. And you don't have to draw that one. It's all going to be scanned and uploaded for you. Okay. Now for this one, let's say we want to find out which intervals it's decreasing. And once again, we're going down and to the right. So if you notice here, make sure it's all level, it's decreasing for this section here and this section there. Okay, so we know since this is going, if you drew this forever and ever and ever, it would go all the way to the left forever and ever and ever. So it's x equals from x equals -infinity to x equals -3. Okay, because once it hits the -3, it stops and it starts going the other direction. So for this one, you're just going to put -infinity to -3. Okay. Then for this interval here, I'm going to start at -1. Two, and it's going all the way, it's going down and to the right forever and ever and ever. So you want to pay attention to that arrow. So it's x equals infinity. So you're going to have your -1 to infinity. So all together, you're just going to combine the two. So you have -infinity to -3, or you can pick from -1 to positive infinity. Uh-oh, sorry about that. Here we go. Okay, any questions on that one? All right. Here we want to find out again where it's decreasing. So we highlight the areas where it's decreasing. Remember, it has to go down and to the right. So between there and there. So that's the decreasing area, or interval. Okay. So you see here, you can tell it's decreasing from -5 all the way to the -2. So you just plug in your -5 to -2. And it's also decreasing from 2, and it's going all the way down to the, yep, so it's going all the way to infinity. So from x equals 2, 2x equals infinity. You go from 2 to infinity. So that means your answer would just be a combination of the two. So -5, -2, or from 2 to infinity. Okay. Any questions there? Okay. So those are examples of when it goes to infinity or comes from negative infinity. You will have a few that won't go from negative infinity to infinity. And where is that? Here we go. But in this case, we're going to just talk about the absolute maximum and minimum. And just like increasing and decreasing, the name kind of explains what it is. The absolute maximum is the highest point in the graph, and the absolute minimum is the lowest point in the graph. Now you can say highest y value. Oh, absolute highest y value on the graph. And absolute minimum is the lowest y value on the graph. Okay. So let's say, for example, they want to find the absolute maximum. Okay. So since they're looking for the absolute maximum, they want to know the highest y value. Okay. And notice here we don't have the arrows like we did before. We have just the closed ends. Okay, so we count the endpoints as part of our, there we go, make sure that's zoomed in enough. As part of what we're counting. So if you look here, you have a high point here and a high point there, but this is tallest. That means that 12 would be your absolute maximum, your tallest point in the graph. Move that up a little bit. Okay. Any questions on that one? All right. Say we have our absolute minimum. Okay. So for there, that's your lowest y value. So you can see there your lowest y value is this point here, which is -1. So that would be your absolute minimum, -1. And for most of them, you don't have to put y equals or anything like that. You just plug in your -1 or 12 or whatever your y value is. All right. Now here, again, they want to know the absolute minimum.